Sir.
Good evening, Pratik.
Sir, my topic for today is fire and electrical safety in the operating room. So to begin with, safety in the operating room is of paramount importance and in the practice of anesthesia. And since operating room is full of expensive electrical instrument, different type of medical gas, etc., it becomes extremely important to be cautious and vigilant for any sort of mishap related to fire. Sir. So fire safety. Fire in the operating room mainly comprises of so-called fire dart, and these must be present for fire to occur: an oxidizing agent, a flammable substrate, and ignition source. Removal of any one of these will extinguish the fire. Examples: oxidizing agents are oxygen and nitrous oxide are the oxidizing agent. Flammable substrate, inhalational anesthetic, endotracheal tube, surgical drapes and swabs, warming blankets, GI gases like methane and hydrogen, skin cleaning agent. Example of ignition source: laser, electrosurgical units, fiber optic instruments, defibrillator, electrical short circuits. Now, just I'm describing in
Even
brief.
drilling machines also they say is a source of ignition. That can also
Yes.
create the heat required. Okay.
Yes. Oxidizing agent. There are many incidents due to due to oxidizing agent causing fire, like leakage of high concentration of oxygen from the nasal cannula or Hudson mask. In fact, even of fire with GA on patient on face mask or via LMA has been also reported on patient on spontaneous or controlled ventilation due to oxygen leak. So therefore, to decrease the risk of combustion, lowest possible FiO2 concentration, that is around 33 to 35%, should be used and maintained so as to ensure the adequate oxygenation and minimal oxygen accumulation is seen in the operating room or within the patient's blanket or the drapes. Oxygen combination with inert gases like helium and nitrogen can also decrease the probability of causing fire. Oxygen and nitrous oxide, they both are very good. Very good. They support combustion very good. So they should not be means, if at all possible, they should not be mixed to avoid fire. Flammable substrate. Historically, inhalational agents like ether, ethylene, acetylene, cyclopropane have been associated with explosion and fire, but current volatile agent does not possess so much risk, and they have negligible risk to cause fire. In fact, halothane, isofluorine, and enfluorine supports combustion, but at very high concentration, which we don't use in the operating room. Endotracheal tube are the substrate for fire during airway surgeries. Therefore, use of helium with oxygen is advocated, or jet ventilation without endotracheal intubation can also be done. Laser resistant ET tube can be done, or use of harmonic scalpel can be also done while doing the airway surgeries. Materials applied or present on the patient are also potent fuel source like surgical drapes. More example, disposable surgical drapes, cotton swabs. To prevent, drapes should be treated with flame resistant chemical. Alcohol solution, which are found in cleansing agent or in the catgut suture, are also associated with OR fire. Therefore, alcohol based antiseptics like powdered iodine, chlorhexidine, methanol or ethanol are not recommended for use in presence of ignition source. If you are using NTG patches, which are also alcohol based, then also extra caution should be taken. GI gases like hydrogen and methane are flammable. Therefore, a low residue diet prior to the day of OT should be practiced, and pre-boil preparation will reduce the amount of flammable gas to 5% of the normal level. And avoid mannitol for boil preparation, which increases the hydrogen production. The insufflation of abdomen while laparoscopic should make sure that we are using carbon dioxide, and which decreases the incidence of operating room fire. Ignition sources. With recent advances, the ignition sources in the operating room have increased, which include electrosurgical units, lasers, fiber optic source, defibrillators, drilling machines. In some temperatures, in some of these devices, temperature reaches up to 1200 degrees centigrade, and thus surgical materials like gauze and cotton will ignite even in absence of oxygen. Therefore, following measures should be used to negate this thing, like use of electrically insulated and non-inflammable hoster to reduce the accidental arcing or direct contact, cleaning the cautery tip to cool, cleaning the cautery tip and let it cool at the operation site before moving the cautery, so that it decreases the chances of accidental ignition of the flammable material. Short circuit should be checked and leaky current should be checked beforehand, and use of line isolation monitor, which we'll discuss in the second part of this topic. Prevention of operating room fire. Legislation should be passed, like political will and commitment for operating room safety and hospital safety should be advocated, and building laws, so that building laws and making sure that it is enacted and followed mandatorily. Like example, Canadian Center for Occupational Health and Safety, CCOHS, or UK's 1997 Fire Precaution or Workplace Regulation Act. Second point for prevention is hospital emergency plans. Promoting safety awareness and education about fire safety. Regular fire drills should be done. Regular checks and preparedness about the accidental fire program should be taking place. Operating room, third point regarding prevention of operating room fires is operating room engineering controls, like mandatorily fire alarm inside the operating room. Now, what if a fire catches? Means management of operating room fire. Principle is removal of one or more element of the fire triad. In small fire or fire around the patient, remove the oxidizing agent. Removing the oxidizing agent is the most efficient thing. So immediately discontinue the gas, as patient can tolerate momentary lack of oxygen. Second thing, the delivered oxygen which was delivered previously will be consumed by the fire and fire will die down. Third thing, gas flow, it may lead to the spreading of fire inside the airway of the patient. So gases should be turned off immediately as soon as there is fire. Discontinuation of the oxidizing agent should be followed by or removal of any inflammable material from the combustion site, which is followed by removal of the heat by cooling agents such as normal saline. For a small fire outside the airway, a wet towel can be used. For moderate to large fire, use a fire extinguisher. Shutting down of the electrical equipments and room ventilation, and evacuating the patient with manual ventilation. Trying to stay as low as possible to the floor during an event of accidental fire, if mishap occurs. Three most important point for successful management of operating room fire are speed, rapid recognition and quick action should be done. Patient safety, it should be of paramount importance, more than our safety also, and patient should be transported as outside the OT as soon as possible. And communication between the member of the operating room team, so as to avoid chaos and mismanagement. So this was fire safety. Now moving on to electrical safety. One of the main concerns in the operating room is leaky current, which is present in all the electrical equipment as a result of capacitive coupling or inductive coupling between the internal components and defective insulations. The magnitude of such leak is normally imperceptible to touch, that is less than 1 microampere, and it is well below the fibrillation threshold of 100 microampere. 1 microampere or lesser or greater is known as macro shock, while the current which is present in microamperes is known as micro shock. So if current bypasses the high resistance offered by skin, current as low as 100 microampere, that is micro shock, can be fatal. Therefore, maximum leakage allowed inside the OR is 10 microamperes. We should be extra careful while cardiac pacing wires and invasive monitoring catheters are in situ or inside the patient, as they can provide directly conductive pathway to the myocardium, and direct shock can be delivered to the patient, and patient may land up into cardiac arrest. Okay, so moving on, electrical safety of the operating room includes, first of all, grounding. Earth is a better conductor than the human body, so if the electrical appliances are grounded, and touching it, it would not, preferentially the circuit will be completed by the ground, and thus patient would not get a shock. Second thing is ground fault circuit interpreter, GFCI. This is a device which monitors the current in the hot and the neutral side of the circuit, and if there is any difference detected, it is assumed that there is current leakage outside the circuit, and thus the power is immediately interrupted. Third thing is line isolation monitor, isolation transformer. Isolation transformer are the means current directly comes from the transformer from outside, and then a separate transformer is present for the OT, which is called as isolation transformer. There are two wirings present in the isolation transformer. Primary wiring is grounded while secondary wiring is ungrounded, and whole of the equipment casing is grounded. So this prevents the patient to get a shock. Fourth thing is line isolation monitor. This device monitors the current leakage to the ground and alarms when leakage is greater than 2 or 5 milliampere, depending upon the age of the line isolation monitor. The alarm also indicates the occurrence of first fault prior to the occurrence of macro shock. Therefore, with line isolation monitor, macro shock would not occur unless and until there are two faults in the electrical circuit. Modern day equipments have decreased the chances of electrocution furthermore, as they have double insulation of the casing and the chassis. Second, ungrounded battery power supplies are present in the separate instruments. And third, patient isolation from the equipment connected by grounding and use of optical coupling or the transformer resistance. So this is how we prevent means electrical safety is present in the device. So I finished.
That's a fairly well written answer. But there is a separate chapter in the Miller textbook of anesthesia and fire and electrical safety, the second volume, where if you read that, you understand that these two accidents are interconnected. That is, fire happening in OT or electrical mishaps happening in the OT, both are interconnected. And in the earlier days, we used to talk about what is called static electricity. And that word I didn't find in your answer at all. I think because you have taken it all from the net with PPTs and things. The static electricity is still one of the important things that you have to mention in your answer for fire accidents in the OT. Because even though your other sources of sparks, like your cautery, your defibrillator, defibrillator we are not using day in and day out, but when it is used and in the presence of an igniting source, it can be definitely a source of creating a fire. So these two are interconnected. That is why this question is always asked: fire and electrical safety inside the operation theater. You have mentioned most of the points. So you have to first identify what are all the sources that can create fire, which you have nicely explained, and the triangle of what the three elements that are required to create a fire is also the drawing you can just draw so that you can avoid time of writing too many sentences. And so having identified all these sources or the chances by which can result in a fire mishap, the first thing I think Miller states is every person working in a OT, not only the anesthesiologist, every person, doctor, paramedical people, they should know the location of the fire extinguisher. That is a very important thing. And where it is located, do you know where it is located in your theater now? If I ask this crowd, I think 95% of the people won't know where the fire extinguisher is in their OT complex. Okay, so this is the knowledge that everybody should first have. One of the safety measures that you know is everybody should be aware where the fire extinguisher is there. And fire extinguishers, usually we use carbon dioxide foam to quell it so that it will cover and it will stop the further spread of the fire. And all the sources of possible fire mishap should always be identified and try to be minimized. And with regard to the prep solutions, what you said is alcohol preparations are nowadays mostly not advocated. Only we use betadine or chlorhexidine for cleaning the skin. So the earlier it was all mainly alcohol based. And one of the things that compulsorily done in the UK theaters, what I heard was, even with the betadine or chlorhexidine, when they prepare the skin 3 times, they wait for the entire solution to dry before they drape the patient. Whereas in our surgeons are very impatient, and as it is cooling down and still the skin is wet, they will drape and wipe it with a Gamgee pad and then start operating. So, but that should not be done. You, after preparing the skin, you allow it to dry completely and then drape, so that pooling of these things do not happen in the dependent area, which is one of the main sources for getting ignited. Okay, so that is a very important safety rule that has to be strictly followed by all the people. But when the list is long and the surgeons are in a hurry, they don't follow all these precautions. And that is one of the reasons that it may land up with a major casualty later on. Okay, so how the fire has happened, there you can mention about the static electricity. So static electricity is a short note question in the theory also. So you have any idea about static electricity? How it is produced, what it can do?
Sir, the major means which we instruments which we are using have a means wheels means due to
You can say it is not instrument alone. Any two objects which they come to
friction.
contact with each other and separate, there is a flow of electrons. Okay, when two objects, whether it may be instruments, whether it may be the drapes or the dress that you wear, the covering that you put on the patient, that is why the synthetic materials cause more static electricity. That is why all our theatre uniform and patient gown are all made of cotton. So the cotton element is one which can prevent this static electricity. Whereas if you have a nice synthetic rayon theatre suit, that is a more riskier thing. So our,
even with the
eh?
even with this disposable ones, we get the electricity, you know. So even when
Electricity,
you
yeah. Even the PPE kit and all that, what we
disposable.
get is all potential sources of static electricity. Okay, so more the cotton element is there, lesser the risk. So, but cotton is much more costlier compared to the synthetic material. So that is why people try to save the cost by adding more synthetic element in the dress and other covering agents. So that is the description of static electricity. When two objects come in contact with each other and separate, there is a flow of electrons which can act as a spark, and then if there is an ignitable source, it can catch fire. In those days, they used to talk about ether. You said ether, no? So the ether is a heavier thing than lighter. So the fire will usually happen at the bottom of the anesthesia machine, because ether will be more towards the floor. And when you, that is why the floors were all made of anti-static in those days. Okay, the floor, your shoes, everything is made of anti-static, because even you are walking with a slipper on the floor can cause static electricity and ignite if there is an ignitable material there. Okay, so that one point you can add in that. And with regard to the electrical things, safety, all of us should have some idea about how the electrical arrangements have been made. Many theaters, you know, they have the electrical plug points at the very, at 1 to 2 feet height from the floor. That is a very risky thing, because water, when they wash the theater, the water can go there, and then once you put in a plug there, it can short circuit and cause a damage or a shock. So the mandatory recommendation is it should be at least about 4 feet away from the floor. So those who design the theater should know where all it should be and try to know what is the level of points, outlets you should have. And it should always be preferably a 3-point socket, so that you can have a grounding element on all the locations instead of the 2-point pins. And whenever any electrical equipment is not used, that outlet point should be always kept switched off. Majority of the times, you will find the switch will be on and you will just put in the plug and then it immediately takes place. That should not happen. After plugging in the instrument, then only you must put the switch on, and it should not be kept in the on position all the time. And the circuit breakers, what you said is GFIC is also called circuit breakers, or the you have a test and reset facility in those circuit breakers. So that should be always the type which you should be keeping, so that you can test whether there is any leakage of the current. And fuses and blowers are very, very important, so that no leak of current will happen. Okay. And when you applying the earth pad for monopolar dithermy, so you can give a little bit more explanation on monopolar and bipolar dithermy, which will be a safer, even bipolar is always safer. So majority of the times you find that the earth pad, which is reused, the metal form sheet where they put a wet pad over that and then place it under the gluteal or the back of the patient. It should have full contact with the patient. That is a very important safety measure that you have to remember. Half-hearted or partially touching earth pad always causes a burn injury to the patient. So that is why nowadays we have the disposable sticking type of pads, which will stick much completely. The entire surface will be sticking to the patient's body. So that is a very important safety measure that all of us should know, much more than the details about other these things. Otherwise, it's a little out of the way question. So you have to keep reading it again and again to remember, so that if it is asked in the exam, you may be able to answer it. At least remember those few points so that you can answer it. Otherwise, you have prepared the question answer very well.
Thank you, sir.
Thank you.
And in the latest Barash Indian edition,
Kamashi?
the latest Barash textbook.
Though Barash,
Indian
Miller,
edition,
and Morgan, all the three give the chapter on this electrical and fire safety is there.
Yes, sir.
What I read was from Miller only. I don't have the other two textbooks, recent
Yes,
ones. I have only old
The recent one,
editions.
Indian edition, they have given ASA's flowchart for algorithmic approach towards fire safety and electrical safety in the theatre, sir. Like our airway algorithm.
Okay.
That covers the question, particular this answer very well, sir.
Okay. So you can circulate that information in the Reza group WhatsApp so that they can read it up.
Yes, sir. Okay, sir.
Okay.
Any questions from the students? Sir, no questions as usual. Sir, can we have any topic for next week, sir? What topic you can give for the students, sir? Last time we discussed pediatric, now burns, and next week can we have any short case questions, sir?
Next week, shall I present some OSCE type of papers, which I prepared last year for the DNB exam going students, where we will show some specimen CCG tracings, ABG reports like that, a mixture of all these things which they can answer and try to.
Yes, sir. That will be nice, sir.
That will be very useful, sir. That will be very useful.
Yeah, I have about 7-8 question papers like that ready. So we can present that and we can go ahead. Initially, there will be one long case, one short case discussion, which we can quickly complete without a case scenario will be given there. Because this pattern was followed during the COVID, because they cannot give the live patients to them. So it was displayed in the video monitors, and then candidates were asked to read that and then answer in a written form all their presentation. And then ASCII, it with pictorial things were displayed and questions were asked. Again, they have to answer quickly within about 5 minutes for each question like that. So for that I had prepared about 7-8 question papers. Each one will contain about 29, that is one long case and 2 short cases, just a spotter identification and quickly the anesthetic management, followed by 27 questions about on varying things like instruments, drugs, ECG, PFT, ABG, like that. By mixture of all the X-ray, everything will be there. So shall we have that one next week?
Yes, sir. I'll gather a list of all exam going students, sir, who have already given the theory and waiting to take the practical exam from all the colleges we are in.
Some of them, all of them are still going only for theory, or practical students also are there?
Many of them are waiting for only the practical, sir. The December batch have already given the theory.
Then that will be useful for them. Yeah, that will be
Yes, sir.
useful for them.
Okay,
Okay, we
sir.
will try one next week. Then based on that, we will see whether we can proceed like that, or we have to change back to theory discussion.
Okay, sir. Sure, sir. Okay.
Okay.
We'll have asking discussions next week. Okay, sir.
Yeah.
4:30.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, Vasanthi. Thank you very much. Good night.
Thank you, madam. And thank you, dear students. With the permission, I'll sign off this meeting. Thank you, sir.